Good day all. Today we're going to be speaking about quadratic sequences. Quadratic sequences are one of the three major sequences we find in everyday mathematics, and the reason that I'm going through it today is because it actually has a very clever method in which they work it out. So before we go into that method, let's first look at an example. So here I've taken quite a complicated example. It's probably the most complicated one you guys will see throughout your whole schooling career. But let's see here. So we have 7, 26, 53, 88, 131. So we can pretty much see that there's no common difference there and that there's no common ratio. So we know that it's not linear and it's not a geometric sequence either. So the first thing we do, we actually do the same thing we do for linear sequences, and we find the difference between all of them. So, but as you can see here, the difference for all of these is very, very different. So we have 19, 27, 35, 43. So we can't use the same method we use for linear sequences to solve this quadratic sequence. Next thing we do to actually help us fix this problem is that we actually find the difference of the differences. So we go 27 minus 19, and we get 8. We go 35 minus 27, we get 8 again, and we get 43 minus 35, and we get 8. And the thing about it, it's the one property of quadratic sequences, is that the second difference that you guys work out, all of them will be the same. That's why we have all those 8s at the bottom, is because that difference will always be the same. It's the one property of quadratic sequences that you have to remember. So if you can see that there's no ratio and you can see that there's no common difference between them, work out the difference between the differences, because it must be quadratic then. Okay, so but now what do we actually do with this? Because we actually haven't been given any equation or any method to do anything with this. So what we do is that we use this equation up here. Tn equals an squared plus bn plus c. Okay? And what we do is that we substitute what's it called? 1n for n to get a plus b plus c, because it's term 1, so we substitute 1n for n because n is what's called the number of terms. So this is t1 is equal to a plus b plus c. T2 will be 4a because 2 squared is 4, plus 2b because the 2 goes where the n is, plus c. Then T3 will be 9a plus 3b plus c, and T4 will be 16a plus 4b plus c. But we still can't really do much with this. So what we do is that we find the differences between all of them. And then you'll see here that we'll get 3a plus b if you find the difference between T2 and T1. For T3 and T2, we get 5a plus b. And for T4 and T3, we get 7a plus b. But once again, remember, we have to do the difference again. So then at the bottom, we get the differences between those terms. So we get 5a plus b minus 3a plus b is 2a. And then we know that all of these bottom ones are going to be equal. So all of these terms at the bottom are going to be equal to 2a. Now that we have this actual big, we'll call it a mind map, so that because it is almost that, so that you can see, now we can actually work out a methodology for how to do this. So let's go back to the previous example. So here we have 7, 26, 53, 81. Yeah, it's the same example that we had. So now what we do is now because we've got the common difference at the bottom, we set 2a equal to 8, because that's where 2a appears on our diagram at the top. So we set 2a equals to 8, and we find a is equal to 4. Then we move up to the 3a plus b, and we see what 3a plus b is equal to. So we have a plus 4, and 3a plus b is equal to 19. So then we substitute the 4 in for a. So we get 3 times 4 plus b is equal to 19. So then and then 3 times 4 we know is 12. So we go 19 minus 12 is equal to b. So b is equal to 7. Okay, simple enough. It seems like we're getting somewhere. Okay, let's move on to the last one. So now, because we know that the top one, the 7, is equal to a plus b plus c, we set them equal to each other, and then we substitute the values that we've worked out for a and for b into that equation. So we get 4 plus 7 plus c equals 7. And then from that, we work out that c is equal to negative 4. So now we're basically done with this example. Now all we need to do is put it into our original formula that we had at the top, that Tn equals an plus bn plus c, and we get Tn is equal to 4n squared plus 7n minus 4. And as I said, that this is probably the most complicated formula for a quadratic sequence you're ever going to find. But like, as you can see, no matter what the formula is and no matter how complicated the sequence is, the method is always very simple and very clear. I hope that this was of some help and it helped you understand quadratic sequences a little bit better. I will see you guys next week. Thank you.